Scientists just found something under Antarctica that should not be alive. Not one creature. A whole hidden world, sealed under ice for centuries, that nobody was supposed to see. A block of Antarctic ice the size of Chicago cracked away, and beneath it sat animals that should have been dead. No sunlight reached them, no easy food fell from above. For centuries, that place was sealed under ice almost 500 feet thick. That alone was strange. But the real shock was not one animal. It was a whole living world. And the deeper scientists looked, the worse the old rules started to fail. Because this was not a lonely survivor clinging to life. It was a thriving community in a place many experts thought should be close to empty. Stay with me, because by the end of this video, you will see why one discovery under Antarctic ice is forcing scientists to rethink where life can exist, how it survives, and what else might still be hiding in the darkest parts of our planet. When most of us picture Antarctica, we imagine a white desert. We see endless ice, violent winds, and cold that burns your skin. It feels empty from a distance, almost like another planet. But Antarctica is not just ice on the surface. It is a giant system. Ice shelves float over seawater. Glaciers grind into the ocean. Deep currents move in silence under layers of frozen cover. And that matters, because what happens under the ice is almost impossible to see. You cannot simply walk there. In many places, you cannot even reach it with normal diving gear. The ice can be hundreds of feet thick, and the nearest open water can be many miles away. For a long time, scientists had a simple idea. The farther you go under an Antarctic ice shelf, the less life you should find. That made sense. Most ocean life depends, directly or indirectly, on sunlight. Sunlight powers tiny plants near the surface. Those tiny plants feed small animals. Small animals feed bigger ones. Even on the seafloor, life often depends on scraps drifting down from above like slow underwater snow. Now picture the opposite of that. Picture a roof of ice overhead. No daylight, no waves, no clear path for fresh food. Just darkness, pressure, and water cold enough to freeze your bones. If you went by the old model, you might expect a few hardy scavengers there. Maybe something drifting through, maybe a worm, maybe a fish passing by. But a rich, stable ecosystem deep under the ice, that was a much harder sell. And yet, small clues kept appearing. Years ago, one strange moment hinted that Antarctica was hiding more than anyone thought. Scientists lowered a camera through a hole in the ice. They were not hunting monsters. They were not even looking for animals. Then, something small and pinkish-orange drifted past the lens. It was a shrimp-like creature, an amphipod, only a few inches long. The place where it appeared was what made the finding so strange. It was beneath the Antarctic ice, hundreds of feet down, and far from open water. That little animal did not prove the whole story, but it cracked open the door. If something like that could live there, what else could? At the time, the discovery felt like a tease, a flash, a hint from a world we could barely touch. It gave scientists a question, but not a full answer. And Antarctica is full of places like that. Places that look still from above but hide motion below. Currents move, water rises and sinks, heat shifts, sediment settles, life adapts. Still, there was a major problem. These hidden spaces are brutally hard to study. Drilling through thick ice is slow and expensive. Sending cameras or instruments into the hole is risky. A small mistake can ruin an entire mission. Even if you do reach the water below, you are still only peeking through a tiny opening. Imagine trying to understand a whole city by looking through a keyhole. That is what Antarctic under ice science can feel like. So for years, the mystery stayed mostly in fragments. But then nature did something no one asked for. In January of 2025, a giant iceberg known as A84 broke away from the George VI ice shelf. It tore free along the Antarctic Peninsula and exposed a patch of seafloor humans had never been able to study directly. This was not a small crack. The iceberg covered about 510 square kilometers. That is roughly the size of Chicago. A piece of the frozen barrier simply moved, and a hidden world blinked open. For scientists nearby, it was the kind of chance you do not ignore. A research team working from the vessel Fall Corps, too, changed course. They knew the window might be brief. Ice shifts fast. Weather turns. Access can disappear almost as suddenly as it arrives. So they moved toward the opening and prepared a closer look. Now imagine being on that ship. You are surrounded by cold gray water, broken sea ice, and huge white walls. The air bites. Every movement matters. And somewhere below you, underwater, dark as ink, lies ground no human eyes have seen. The team sent down a remotely operated vehicle, a robot built for places people cannot survive. It carried cameras and lights. It could descend into the deep and show the crew what the seafloor looked like after centuries under ice. What they expected was not nothing, but it was not what they got. As the robot moved through the dark, shapes began to appear. First the seabed, then life, then more life. Sponges, corals, sea anemones, fish, giant sea spiders, octopus, not scattered remains, not a few struggling bodies. A living community. That was the first punch. The second punch came with size. Some of the sponges were large, and sponges can grow very slowly, sometimes less than 2 centimeters a year in such cold places. That means a big sponge is not a recent visitor, it is a sign of time. A sign that life did not arrive last week. It had been there for decades, maybe much longer. That changes the feel of the discovery completely. It is one thing to find an animal that wandered into a harsh place and got lucky. It is another to find an established ecosystem that seems to have lasted in hidden darkness for years, perhaps centuries. And remember what sat above it. About 150 meters of floating ice, a frozen ceiling almost 500 feet thick. That is where the story stops being just cool and starts becoming deeply strange. Because if these animals had been living there for so long, then they had solved a problem no one had fully explained. They had found a way to eat, grow, and reproduce in a place cut off from easy surface food. So where was the energy coming from? That question is everything, and the answer gets stranger the closer you look. In the normal ocean story, surface waters matter a lot. Tiny floating plants use sunlight, then bits of that living material drift down. It is not glamorous, but it feeds much of the deep sea. Under a thick ice shelf, that supply should weaken. The farther you go from open water, the worse it should get. At least, that was the old thinking. But the George VI discovery suggested the real system is more complex. Scientists believe ocean currents may carry nutrients sideways under the ice. Instead of food falling from directly above, some of it may be swept in from far away. In simple terms, the hidden ecosystem may survive because the ocean acts like a delivery system, moving life-supporting material into places we assumed were starved. That idea sounds simple until you picture the distance. These are not short little trips. Antarctic water can move through huge hidden spaces below the ice. Nutrients can travel along routes no one at the surface would ever notice. It is like learning that a sealed room is not sealed at all. It has invisible hallways. But here is where things get even more unsettling. The George VI discovery was not the first time Antarctic life broke the rules. It was just the clearest. Back in 2021, another team made a finding beneath the Filchner-Ronne ice shelf in the southeastern Weddell Sea. That place was even more extreme in some ways. Scientists drilled through about 900 meters of ice. That is almost 3,000 feet. Below that ice, they were around 260 kilometers from the open ocean. Picture that. You're not a short swim away from daylight. You are deep under a frozen roof, incredibly far from the nearest easy source of food, in total darkness. The water there was around minus 2.2 degrees Celsius. Salt water can stay liquid below the freezing point of fresh water, but that does not make it friendly. It is still a brutal environment. The team was not even looking for a thriving animal garden. They were trying to collect sediment from the seafloor. In plain words, they wanted mud. Instead, they hit a boulder. That alone was unexpected. But when they looked at the video from below, they saw something even stranger. The rock was covered with life. Stationary animals. Animals attached to the boulder. Animals that looked like sponges and other filter-feeding creatures. That should not have made sense. Filter feeders live by pulling tiny bits of food from the water. If the supply is weak, they are usually among the first animals you would expect to disappear. Yet here they were, living deep beneath an Antarctic ice shelf, farther from sunlight than many experts thought practical. The lead researchers said the discovery raised more questions than it answered. That was not scientific caution. That was honest shock. How did the animals get there? What were they eating? How long had they been there? Were they common, or was this one lucky outpost on one lucky rock? Were they known species, or entirely new ones? That single boulder became a problem for the old map in people's heads. And once the old map breaks, you start wondering where else it is wrong. This is what makes Antarctica so powerful in stories like this. It is not just remote. It hides data from us. It keeps the truth behind barriers so thick and dangerous that whole chapters of reality stay invisible until accident, luck, or technology finally cuts a hole through. And sometimes the discovery comes by accident. That matters more than it sounds. We like to imagine science as a straight line, a plan, a mission, a clean answer. But many big discoveries begin with someone trying to do one thing and stumbling into another. The boulder under Filchner-Ronne is a perfect example. They went for mud and found a rule-breaking community. The iceberg at George VI is another example. A giant slab broke away, and suddenly humans could enter a place they had never seen before. Nature did not wait for permission. It opened the door when it wanted. Now at this point, you might be thinking this is only about Antarctica, a weird corner of Earth, like a one-off frozen mystery, but that is exactly where the story starts to widen. Because when scientists say life exists where it should not, they are not just talking about one spot on a map. They are testing a much bigger idea. Can life survive with almost no sunlight? Can it survive far from simple food sources? Can it persist in darkness under crushing pressure with water at the edge of freezing? Each time Antarctica answers yes, the limit moves. And when the limit moves on Earth, it changes how we think about worlds beyond Earth. But before we go there, stay with the Antarctic story because the details keep getting stranger. During the George VI expedition, the robot explored depths down to around 3,300 meters. That is deep enough to make the ocean feel less like water and more like space. Light from the surface is gone. Pressure is enormous. Every meter down feels farther from the human world. Yet the seafloor was not empty. There were large corals growing in silence, sponges rising from the bottom like pale towers, ice fish moving through the dark, giant sea spiders walking on long, thin legs that make them look almost unreal. If you saw them without context, you might think they belonged in a science fiction film. And maybe that is part of the emotional power here. These creatures are real, but they seem wrong in the best way. They live where our instincts say life should fail. They look ancient. They look adapted to another age. Some reports from the mission also described a giant phantom jelly in the region, with a bell more than a meter wide and long ribbon-like arms. Even if it was not the core discovery under the shelf itself, its presence added to the feeling that this whole hidden seascape had been waiting for us in plain darkness. You have to imagine how the scientists felt watching those video feeds. Every few seconds, a new shape, a new animal, a new problem for the old theory. That is not just exciting, it is disorienting. Because science depends on models. Models help us predict what should be there. If your model says one thing and the camera shows another, you have work to do. And Antarctica is merciless about that. It does not care what seems logical from a desk. It runs on real physics, real currents, real chemistry, real adaptation. Some of the most important parts of the discovery are not dramatic in the usual movie sense. There was no attack, no giant beast lunging from the dark. The real shock was steadier than that. It was the simple fact of abundance. There was enough life down there to suggest history, enough to suggest stability, enough to suggest the hidden system was not a freak accident. That idea hits hard once you sit with it, because it means whole communities may have been living and dying under Antarctic ice for longer than our instruments have been able to reach them. Worlds under our feet, entirely real, almost entirely unseen. And here comes the turning point. The discovery was no longer about whether a few tough creatures could endure impossible conditions. That old question was too small. The real revelation was that Antarctica may contain ecosystems built around survival strategies we barely understand. That changes everything. It changes marine biology, because it means food webs under the ice may be more active and more complex than expected. It changes climate science, because these ecosystems are tied to ice shelves that are changing as the planet warms. And it changes the search for life itself, because Earth is showing us, once again, that life can take hold in places once written off as dead. Think about how fast the meaning shifts. At first, a shrimp-like animal beneath the ice looked like a strange sighting. Then a boulder covered in stationary creatures looked like a rare exception. Then a vast, newly exposed seafloor showed a thriving ecosystem. Put those together, and the pattern becomes impossible to ignore. Life is not only surviving under Antarctic ice. In some places, it has been quietly building communities there for a very long time. That is the moment the story tilts. Not from mystery to answer, but from one mystery to a larger one. Because now we have to ask what supports those communities over time. Currents are one likely answer, but not the whole answer. Nutrients carried under the ice may help sustain filter feeders. Meltwater may influence chemistry. Tiny particles may move along hidden paths. In some places, chemical energy may also play a role, at least for microbes. Not all life needs the same menu. Some organisms can live off reactions involving minerals or methane or other compounds. On Earth, biology is often more inventive than our first guesses. And that brings us to something easy to miss. Big animals like sponges, corals, fish, and octopus are only the visible part of the story. Beneath them is a deeper layer of life, microbes. Tiny living cells can survive in places that seem empty to us. They can live in sediments, in isolated water pockets, in dark, cold environments with almost no obvious energy. They are the quiet workers of extreme ecosystems. If microbes can persist in such places, they may help support larger systems directly or indirectly. They may recycle nutrients. They may form the base of local food chains in ways we still do not fully understand. So when the camera shows a sponge on a rock, you are really looking at the top of a much bigger hidden process. That is why discoveries like this hit scientists so hard. The video gives you animals, but the real treasure is the network behind them, the chemistry, the current flow, the sediment record, the age of the community, the question of how isolation shapes evolution. This is where the story gets even richer. When a habitat stays hidden for a long time, animals there may become unique. They may adapt in ways that differ from relatives in open water. Some may even turn out to be species never described before. The team that studied the George VI area said some organisms might be new to science. That should make you stop for a second. We still live on a planet where giant cold ecosystems can hide unknown species under Antarctic ice. Not in the age of sail, not in some lost century now. That matters because people sometimes talk as if Earth is already cataloged. as if every major frontier is gone. But the deep ocean keeps proving otherwise, and Antarctica may be one of the last great blind spots. It is remote, dangerous, expensive to reach, and hidden under moving ice. In other words, it is perfect at keeping secrets. But there is a darker side to that timing. Many of these ice shelves are under stress. As the climate warms, parts of Antarctica are changing. Ice shelves can thin, crack, and calve huge icebergs. That process can expose hidden ecosystems, yes, but it can also threaten them. The same event that lets us see a secret world may also help destroy the stable conditions that world depended on. That gives this story a sharp edge. We are finding these places because the ice is changing. And the ice is changing because the planet is changing. So every new look carries a strange mix of wonder and warning. You are seeing beauty, but you may also be seeing it at the start of disruption. Imagine a community that spent centuries under a dim, protected system, suddenly facing altered currents, changing temperatures, and a new relationship with the open ocean. Some species may adapt, others may not. Scientists are not only racing to discover these ecosystems, in a way, they are racing the clock. Now let's slow down and answer the big question more clearly. How can life survive where it seems like no life should survive? The short answer is that our first picture of such places was too simple. We used to think of an ice shelf as a giant lid. Once you went far enough under it, food would run out and life would fade. But the ocean under that lid is not static. Water is moving all the time. Some currents slide beneath the ice. Some water masses carry dissolved nutrients and tiny particles. The underside of the ice itself affects circulation. The shape of the seafloor matters too. Picture a city hidden under a roof, but still connected by tunnels, pipes, and delivery roads. From above, it looks sealed. From inside, supplies may still arrive. That does not make the environment easy. It only means it is connected in ways we were slow to measure. Then there is time. Life in Antarctica does not need to rush the way life in warmer places often does. Growth can be slow, metabolism can be slow, communities can build over long periods. A sponge does not need to race, it only needs enough. That changes our sense of what survival looks like. Yet we often imagine success as speed and abundance. But under Antarctic ice, success may mean patience. Hold on. Filter what little comes. Grow millimeter by millimeter. Outlast the darkness. There is something almost unsettling about that. These creatures are not beating the environment with force. They are cooperating with it through extreme adaptation. They live on its terms, not ours. And those terms can seem brutal. No sunrise, no seasons you can see. Pressure that would crush human bodies. Cold so deep that metal machines and planning all get tested. Yet life remains. This is why Antarctica feels like a rehearsal stage for other worlds. Not because it is identical to them, but because it shows how biology can push past what feels reasonable. Think about the icy moons in our solar system. Europa, one of Jupiter's moons, hides a global ocean under thick ice. Enceladus, a moon of Saturn, also appears to have a subsurface ocean. In both cases, sunlight at the ocean level is not the main story. So when we find life under Antarctic ice, scientists naturally pay attention. Earth is giving us examples of survival in dark, cold, covered oceans. Not proof of aliens, not a shortcut, but a real lesson. It tells us not to be lazy with the word impossible. And maybe that is the deepest shift this Antarctic discovery creates. It does not just add one more odd animal to a list. It attacks our confidence about the edges of life. Humans like boundaries. Too hot, too cold, too deep, too dark, too remote. But life keeps treating those lines as suggestions. Still, we should be careful here. The phrase, "no life should survive," is dramatic, but the real science is more subtle. These places are not magic. They obey rules. We just do not fully know all the rules yet. That is even more exciting, if you ask me. Mystery feels cheap when it depends on fantasy. It feels powerful when it comes from reality we have not understood yet. Under Antarctic ice, the mystery is real. It is measured in drill depth, current flow, temperature, distance from open ocean, growth rates, and video footage. And each new expedition adds a few more pieces. The 2010 amphipod showed mobile life beneath the ice. The 2021 Boulder community showed stationary animals far deeper under cover than expected. The 2025 George VI mission showed rich ecosystems on newly exposed seafloor, with animals large enough to prove long-term survival. That sequence matters. It is not one random clip. It is an expanding pattern. And patterns are what change science. Once enough clues line up, the old view stops holding. Then the hard work begins. New models, new missions, new instruments, new questions, new